Hi, welcome to my Tribe Talk. My name is Lucas Fittipaldi, and this is an electrical shortage and digital transformation. In this presentation, I'll be addressing the problem, highlighting the wicked problem, addressing the current situation and impact. Then I'll be presenting a potential approach and its execution plan. Finally, I'll be concluding this presentation. A little bit about myself. I come from a working class immigrant family, originally from Brazil, that work in the construction industry as electricians. The My interest in the trades led me to study project management as a career by transitioning from program controls, financial management, and a master schedule roles within the oil and gas as well as scientific industries. One of the problems that I encounter is one that particularly addresses why more young people don't join the skilled trades profession. In my walks of life, I've encountered some brilliant and very smart executives with skilled trade backgrounds, and I often ask myself why this isn't a more common route. So my wicked problem led me to uh, investigate the disparity between electricians entering and exiting the workforce, presenting challenges in estimating rising labor, assembly costs, and project profitability, or even feasibility. You see, electricians in the US are reaching retirement age, leading to a need for more skilled electricians. According to the National Electrical Contractors Association, 7,000 electricians enter the workforce and 10,000 retire yearly. This takes 56% of the eligible workforce away. The increase in electrical demand and consumption is also exacerbated by the demand or the increasing demand for electricians. This is projected to increase from 2020 to 2030 by 14% a year by the Projection Central Department. So, looking at the current situation and impact, the shortage slows down projects. It increases customer costs. It limits the adaptability of organizations to shuffle their workforce, and it also creates challenges in cost engineering. Some of these potential approaches, or at least the potential aim of a digital transformation, is to create a streamlined and cutting edge environment consisting of BIM collaboration or building information modeling, uh, estimating, smart timekeeping, project scheduling, cost analysis, and data file sharing across technological platforms. Building an IoT or an Internet of Things, a robust framework that can streamline the estimating process, reduces the need for on site electrical surveying, and further, the integration between BIM and Revit will also decrease the need for on site installation with prefabricated assembly items. This could increase collaboration with general contractors. There is a value proposition with customer streams to increase collaboration with general contractors, architectures, and as well as just collecting valuable data that can increase collaboration between several stakeholders, investors in projects. I do believe that a digital transformation can also open the door for more digital implementation, which can only serve to increase the viability and the feasibility of the organization. And looking at the approaches, or at least the benefits of these approaches, is that in prefabricated assembly items, um, they are designed to integrate into smart systems. So by utilizing the full architecture of the IoT, electrical contractors can create quantifiable intelligence on financial, factory, and product performance. The workflow then demonstrates how utilizing the BIM process, smart prefabricated materials, and the timekeeping tools can help track the progress of learning by electrical contractors, or at least the learning curve against trade laborers, as well as maintenance systems surveying. So as things can break down, a digital IoT can encompass the shortcomings of prefabricated items and then allow electrical contractors to change them without going on site or surveying. potential problems. So as we look at the digitization of the electrical industries, manufacturers like Schneider Electric are beginning to provide BIM-friendly data, and they are a big electrical supply shop. And so allowing people to integrate their tools in their own 3D models can really incorporate collaboration within these models uh, to integrate dimensions, integrate electrical items like switch gears, pumps, motors to the exact scale. And this allows the site surveyors to create real-time collections, and they can determine uh, length, width, depth of each building element without going on site, without having assembly on site, and without sending a crew on site, which is a leaner model that this architecture can provide. Prefabrication of assembly items are also becoming more common. I do think that the modern journeyman electrician needs to learn a lot of these skills uh, as other companies and other electrical contractors adopt leaner methodologies to circumvent uh, the disparity of electricians entering and exiting their workforces. And then finally, digital timekeeping integration uh, with the ERP and other digital data visualization tools is an important feature of our approach. The ability to track shop floor assembly times, on-site assembly or on-site installation, and integration into a financial and scheduling planning system is crucial to building the sort of value stream map that can create value into how long things take and how can we certainly improve on these items. So this is a demonstration of the BIM modeling architecture. Here we see that consultants, planners, architects, facility managers, and systems integrators all collaborate within this 3D model that don't require on-site or um, crews to come out and work or have to do rework if things are installed incorrectly. This allows collaboration within the model so everybody knows we're looking at the same thing. And it's real time, it's live data. This will facilitate concurrent thresholds so people can set concurrent thresholds like architects can set their safety measurements that can then be uh, analyzed on the model and then replicated on site for installation. Now, looking at the softwares that are going to be identified for this integration, we specifically chose Naviswork and Revit. Now, Revit is used primarily as a 3D modeling software. So Revit will be where you build the 3D tools, and then Naviswork takes those 3D tools and creates detections and allows clash detections or issues and program issues or performance issues that allow the architect or the facility manager or other uh, collaborative quality assurance people to input their designs on those parameters. So you can have collaboration or at least adjudication before you get on site. And these are these two tools work very well together. There's an add-on within Navis or Revit for Naviswork so that we can use both tools concurrently without having to switch off or switch on. And an example of that is Naviswork on the left and Revit on the right. This is a visual showing how the 3D model on the right then exports into uh, the review on the left that can then create detection models for exporting. And fundamentally as well, by creating this value stream lean uh, methodology, timekeeping is essential. Timekeeping with Harvest is increasingly simple as they have a mobile and a desktop application. They have timers that are allowed to be configured by the specific project and task with notes available. And then this actually exports into an Excel sheet, a very clean flat file Excel sheet that can be then integrated into an ERP or a schedule. And this is perfect for a production environment where supervisors might be overseeing journeymen or other electricians that are working to sort of populate that value stream demand cycle. And we're also looking beyond just the minimal viable product. So in the true spirit of digital transformation, it wouldn't be fair to explore those softwares without exploring the possibility of increasing that software and creating more data that allows managers to make decisions based off a comprehensive and realistic data. So here we have an integration with Power BI that integrates from Navisworks, and this goes into Power BI where you can create filters or slicers that allow the 3D model to pinpoint by color exactly where clashes occur. You can do it by department or by discipline specifically to see who's doing what uh, or who's responsible for this item that may create issues. And furthermore, we can even expand just the BIM modeling architecture to include planning with Primavera or P6 and management or data visualization tools that can create those visuals that you can then present to your C-level executives and your project management data driven metrics. Now, for an execution plan, I've designed a simple plan, design, develop, readiness structure. And the idea is that between weeks 1 and weeks 5, beginning of week 6, the planning stage requires a high level work breakdown structure, a procurement plan for the non labor items that subcontractors and the consultants use for Revit, Naviswork, the installation consultants, and a responsibility assignment matrix or a RAM to assign key personnel into designated roles to make sure that the implementation is a success. The design phase will then create a stakeholders engagement plan, create communication plans, decompose those high-level WBSs into smaller achievable WBSs, run a feasibility report on those decomposed WBSs against functional elements and vendor selections, and then we can adjudicate the minimal viable product with a project management control system so that we know the budget, the execution, and progress. Then in developing, we kick off the project. We have those procured items then start being installed. We install the AWS, the cloud instances, the solutions to the cloud, and pass a quality assurance test from weeks 12 to weeks 13 to assure that the performance data coming out of those tools are correct. And then last is the test readiness. This is where from weeks 14 to 20, we're working on creating standard procedures, getting the business processes updated and finalized. The cost and schedule are then produced and finalized. Last POs, purchase orders, are then produced. We update the lessons learned log, and we can then create an iteration for a further digital transformation program or project. And it wouldn't be fair without the true digital transformation spirit to say that the secret of change is to focus all of your energy not on fighting the old, but on building the new. We're constantly looking to create a progressive and innovative field that can attract trade trade workers into the industry. We want to provide further implementations and further digital implementations that will only increase prefabricated assembly items, um, combining the BIM model software architecture, and as well as constantly improving our timekeeping and financial. So thank you. It was a pleasure to work with everyone on this in this class, and I hope you enjoyed my tribe talk.